Welcome to another session. My name is Dinakaran. I'm a Cloud Solutions Architect. We're going to look at what a VPC is in the context of AWS. Before we understand what a VPC is, I need to introduce a couple of terminologies that correlate to uh, AWS. So AWS has data centers all over the world. The way they have arranged this is regions and availability zones. Regions are geographical grouping of data centers. Uh, for example, in the United States, they have data centers in the east, in west, and within west itself they have the Oregon and the Northern California region. So it is geographical grouping of those data centers. That's what it is. And within that geographical grouping, uh, one or more data centers can make up what is called as a availability zone, and all your compute resources when you create are going to be within these availability zones. And for high availability reasons, people normally create their compute resources duplicated in multiple availability zones. So if one availability zone goes down completely, they can create in the other one. So that is regions and availability zones, and these availability zones are connected through low latency. So now let's look at what a VPC is. So within the AWS infrastructure, you can create what is a VPC, which stands for Virtual Private Cloud. Uh, think of this more as your own private data center in the cloud. That's how a VPC uh, is defined as. And when you create a VPC, you get to define a address CIDR address block, uh, which helps you isolate your compute resources into separate network zones. So, for example, in this entire structure, I have two deployed resources into two availability zones. So this could be US East 1A and this could be US East 1B, and within this I can have multiple subnets. When you split your network into further subnets, you have control over which subnet can talk to which subnet, and you can make that all through the router here. And also you can deploy something called a security group in front of your EC2 infrastructure that can also provide further rules as to which subnet can send traffic where. So that's how you can use the subnets by controlling what traffic goes in or or communicates to other subnets. So that's what the subnet offers in terms of control over the traffic. So if you expose a subnet to the internet, that would be a public subnet. And if you isolate your compute resources in a subnet, without having incoming traffic, that would be a private subnet. So all these subnets can talk to each other through routes that are defined. So this is how the entire VPC structure is arranged. And if a compute resource need to reach out to the internet, it needs to go through what is known as an internet gateway, which you need to define so that your resources can go out to the internet. And I haven't defined a NAT gateway here. NAT gateways are normally used if you have resources in the private subnet. Let's say these two are private subnets. If they need to pull any software downloads or anything like that, but inward traffic is not allowed for either of those subnets. In those cases, we can define what is known as NAT gateway, through which these subnets, or the resources within these subnets can make a call out to the internet and pull, something like a software update or something like that. So that is the entire setup for VPC. Hope you enjoyed the session. And if you have any questions, you can post your feedback in the YouTube channel. Thank you.